Hello everyone and welcome to another National 5 course video on surds and indices. This lesson is going to be the last lesson looking at surds. Alright, and what we've got is looking at being able to rationalise the denominator of a surd. Where that kind of comes from, well, I mentioned in the last video about a little bit of a health warning about using your calculator to check answers. I don't know if you'll remember, but I gave an example of 1 over root 2 where the calculator will spit that out as root 2 over 2. Then you'll get confused and wonder what's wrong. This lesson is going to take a little look at the reasons why, essentially behind the calculator doing that. So, rationalising the denominator of a surd. The success criteria, right? So how we're going to do this, we look at knowing that rationalising the denominator of a fraction involves writing the denominator without a root sign. Okay, that's what it involves. That's the purpose of it. And to do it, you multiply the top and bottom of the fraction by the surd on the denominator, and then simplify things as far as you can. So we look at a couple of examples here. Rationalise the denominator in these fractions. Right. So what have we got? We've got the first one there, 5 over root 3. Now, let's talk a wee bit about the why. The denominator of the fraction 5 over root 3 is an irrational number. Okay, and quite often it's way more convenient to have the fraction written with a rational number on the denominator as opposed to an irrational number on the denominator. So 5 over root 3 has an irrational number, it has that surd on the denominator. We're going to fix that just now by doing a very quick and easy process. And what you'll find is that the answer will have a whole number on the denominator rather than a surd. Okay, so that's the point of it, that's why we do it. And it's dead easy to do. All you need to do is use an equivalent fractions technique. So remember, we can keep the fraction equivalent by multiplying the top and bottom of the fraction with the same thing. It has to be the same thing. And what we do to rationalise the denominator is we just multiply the top and bottom by whatever the surd is on the denominator. Okay? And the reason why we do that is because the square root of 3 times the square root of 3 is just going to be 3. Therefore, we've just made our irrational number into a whole number. Okay? So, 5 over root 3 is going to become 5 root 3 on the numerator divided by, now root 3 times root 3 is just 3. Right? Remembering that root 3 times root 3 is root 9, which just comes back to 3. So we can save ourselves the hassle of working that out by remembering a surd times itself is just a number under the root sign. Okay, and the fraction 5 root 3 over 3 doesn't simplify, the surd root 3 doesn't simplify, and 5/3 doesn't simplify. So we can't take that any further. But my final answer has a whole number on the denominator. So i.e. has a rational denominator. Let's have a little look at the last example here. So we do the same sort of thing, we times by root 5 top and bottom. Okay, and what we're getting here is root 8 times root 5. Root 8 times root 5 over root 5. Now, root 8 times root 5 is root 40 over root 5. Now, we do need to simplify these things though, because square root 40 is a surd that simplifies, and we need a square factor for square root 40, so we'll have 4, so we'll take square root 4 times square root 10 over, I made a mistake with that, didn't I? Jeez, oh, let me go back a little step, rub that out, let's go back. Let's pretend that didn't happen. Right, let's just come back a little second, because that denominator is wrong. Okay, root 5 times root 5 is 5. Okay, so we've got root 40 over 5. Right, that's better. Right, let's tidy it up. Root 40, as we said before, square root 40 is square root 4 times square root 10 all over 5. So that's 2 root 10 all over 5. There we go. Right, that's better. So, mistakes happen, you know. So, when you're rationalising the denominator, just remember, all you need to do is times the top and bottom of the fraction by the surd, okay? So if it's root 3 that's on the bottom, times the top and bottom of the fraction by root 3, okay? And you'll always end up, the result will always be, it'll end up with a whole number on the denominator, which is why we do it that way, because we want to rationalise the denominator. Right, this is very much an extension one, okay? So this is optional. You will not get asked this really at National 5, but I know there are some of you out there that would be keen to see something like this maybe. So let's have a wee look. Write 3 over 4 plus root 2 with a rational denominator. If we applied the same technique as we had before, right? Let's times top and bottom by the surd. So times top by root 2 times the bottom by root 2. Right, well what we get is 3 root 2 over root 2 times 4 plus root 2. Okay, hopefully you can maybe see where this is going. 3 root 2 over 4 root 2, just multiplying that bracket out, plus 2. Well, that's no help, isn't it? No, like that's still irrational. Because it's got root 2 on there, so that's not really any use to us. So we need a slightly different, when there's more to it than just the surd on the denominator. So in this case, you know, it's the surd plus 4. We need something better or different, not necessarily better, but we need something different. And what we do is, instead of multiplying by the surd, we multiply by the conjugate surd. Okay, now the conjugate surd, the conjugate surd to 4 plus root 2, right? So 4 add root 2 has the conjugate take away root 2. Right. So what you're really doing is just changing the sign in the middle. You're not changing the numbers. The conjugate to 4 plus root 2 is 4 take away root 2. Likewise, the conjugate to 4 take away root 2 is 4 plus root 2. So all you're doing is just reversing the sign. And the reason why we do that is because I'll show you it with 4 plus root 2 in a wee second, but if we take something like 3 plus root 5, right, and multiply that by the conjugate of that, so 3 minus root 5, the result to that multiplication will always be a whole number, right? And the reason it will always be a whole number will become clear in a wee second. Let's multiply this out. 3 3s are 9, and then we're going to take away 3 root 5, and then we're going to get plus 3 root 5, and then we're going to get root 5 times minus root 5, so the result's negative, because it's positive times a negative. Root 5 times root 5 is just 5. 9 take away 5, that's 4. But look what will, this scenario, you will always get, right? You will get a positive answer, take away the same thing, and you will always end up with 0. So the surd part will always vanish when you do something like this, okay? So the multiplication 3 plus root 5 times 3 take away root 5 is just 4. The surds go. And that is why multiplying by the conjugate surd works. Okay, so let's do it for 3 over 4 plus root 2. Right, multiply top and bottom by the conjugate, so multiply by 4 minus root 2 on the top and multiply by 4 minus root 2 on the denominator. So we'll end up with 3 times 4 take away root 2 over 4 plus root 2 times 4 take away root 2. Right, so deal with the top. Well, it's just a single bracket. 3 4s are 12. 3 times root 2 is 3 root 2 over. Right, let's do the same as what we did above there. Right, so start with the first. 4 4s are 16. Do the outsides. 4 times negative root 2 is take away 4 root 2. Do the insides. We get 4 root 2. And then do the lasts. Root 2 times root 2 is just 2. No, you'll get take away 2 there. Okay. So, take away 2. So we get 12, take away 3 root 2, all over. Well, the third parts cancel out, and 16 take away 2 is 14. Right, 14 is a rational number, so job's done. We've written it with a rational denominator, and you can put that into the calculator and test it by putting the question into the calculator, and it should spit out what you've got at the end there. Okay, so as I say, that's just an extension part to rationalising the denominator. You won't get asked that at National 5, but some of you might be interested, and the questions are there in the worksheet anyway. Alright, so that's the end of the third part of the unit. Let me know if you need any help. As ever, just drop me a wee email. Thanks very much.